Hello and welcome to our video today. So today we are going to do stoichiometry, but before that, let's review some of the concepts that you might need to have before we start solving for stoichiometry. So first, let's talk about solving for the molar mass. A reminder: if you look into your periodic table, if you have your periodic table with you, you can actually see these numbers like this. Okay, so in your periodic table, for each box, what you're going to do is this will be the specific mass of each element that is in a chemical. So let's just say we have C6H12O6. This will be your glucose. So for example, for your carbon, you have 12.01. Okay. So for this one, since this is 1, you'll have 12.01. The next one for your hydrogen, you'll have 1.0. Since this is 8, this becomes 1 as you write it down. So this will have 1.01, 12.01, and this one is going to be 16.00. But I think some of the issues is some of the periodic tables might have a different means of writing things. So for some periodic tables, like mine, it has carbon at 12.00. Although that's just a very small difference when it comes to the calculation. I hope it will have a very standard means of measurement, and I think the more accurate one will be 12.01. So let's try to solve for the molar mass. So 6, oh, sorry, 9 instead of 6. Just write down in a column formation all of your elements. So C H O, then followed by an equal sign, and then you write the number first. So 6, 12, 6. So for carbon, you write 12.01 and equal. For hydrogen, 1.01. For oxygen, you'll have, oh, sorry, not 6. 1, 6. So 12.01 times 6 is going to be 72.6. For your 1.01, 01 times 12, that's going to be 12.12, and then you'll have 16 times 6, which is going to be 96. 76 plus 12.12 plus 72.06 is going to be 180.18. So this will be a very vital thing. So please, I hope this small drill would be able to make you remember at least some of the things that you have to remember for your stoichiometry today. Now, another thing, okay? Let's remember the law of conservation of mass. So the law of conservation of mass. Okay? So from what we've talked about regarding balancing, okay. So the main principle that we need to have is this. All of the number of elements should be the same on both sides. So for example, if this has, that's why we balance this, right? If we have if we have 2 times 4 for hydrogen molecule, you're in the product side, you need to have 4 as well. Okay? And since this is 2 oxygen, you're going to need 2 times 1, 2 oxygen. The law of conservation of mass is being followed here in stoichiometry and in balancing. So for example, if you have here 4 hydrogen, So you'll have here 4 hydrogen molecule and 1 oxygen molecule. You can create 2 dihydrogen oxide. So H O H, then you'll have H O H. So by just by means of counting, you can actually see that 1, 2, 3, 4 H, 1, 2, 3, 4. You'll have 4 H. And you'll have 2 oxygens and 2 oxygens. So we say the law of conservation of mass, since they have the same number and they would have the same atomic weight, they would have the same as no mass is going to be lost. However, the molecules on the product side, I mean on the reactant side, is different from the product side. Okay, anyways, that's the 2 general concepts that you need to remember. Now let's talk about stoichiometry. Okay, so stoichiometry is the relationship between the relative quantity of substances taking reaction. So this is just a mathematical expression of how things will work based on the relationship that is going to take part in the reaction. So you're basically describing what is happening and how much of stuff are going to be made out of this specific type of compound. So let's review. What are the skills that you need? First one, you need to have a you might be at least capable of balancing an equation. You need to be able to solve the molar mass, and you have an understanding of the law of conservation of mass. If you don't understand this, you might as well review some of the videos before proceeding with this one. So let's have a sample here. Okay, so in our problem solving, okay, remember that this is 1 mole. Okay, again, 1 mole is just a specific unit for each type of for each compound or molecule or substance that you have in a problem. So for example, if you solve for the atomic mass, okay, the atomic mass is usually 1 mole of that compound. So for example, the atomic mass of this is Fe2, and O3. So 2 and 3. So Fe or iron is 55.85, and oxygen is going to be 16.00. So 55.85 times 2 is going to be 111.7, and then your oxygen is going to be 16 times 3, that's going to be 48.00. So 48 plus 101.7 is going to be 159.7. This will be grams per mole. So this is a 1 mole unit of measurement. So 1 mole of Fe2O3 is equal to 159.7 grams per mole of Fe2O3. That's how you solve for your molar mass. And remember, the molar mass is equal to 1 mole of that same compound. Now for this one, how much mole of Fe2O3 is in 5 grams? Okay, so remember, 1 mole is 159.7. So by that ratio, you'll have an idea that it's going to be much lower than 1 mole, because 1 mole is 159.7 grams per mole. So how do you solve for that? Okay, so we'll write down your given unit of measurement. So for grams, okay, you need to convert that given mass or your mass that is given into mole. So 5 grams of Fe2O3 times, okay, you are going to use now your given, okay, so your conversion factor. So since this is 5 grams, it looks like 5 grams, okay. So since this is mass, the molar mass should be placed underneath. So 159.7 grams per mole of Fe2O3, or just grams. Okay, I forgot to place grams per mole here. So let's just use grams. So we'll have a similar approach. And then you'll have here 1 mole of Fe2O3. So cancel grams of Fe2O3. Cancel this one. So you're left with the mole. This will be your unit. So 5 times 1 divided by 159.7. The number of moles for this one is 0.03. It's barely 1%. So you'll have 0.03 moles of your Fe2 or iron 2 oxide 3 or iron trioxide. So moles of iron trioxide. Anyways, that's how you solve for this one. So this is how you convert from the given mass. By the way, this is a given mass. This is not going to be your molar mass. Your molar mass is going to be the ratio, or I mean 1 mole is equal to the equivalent of your molar mass is going to be 1 mole. Okay, so that will be your standard for your conversion of basic units.